Welcome to Lionheart Academy. My name is Richard Tsai. Today we're continuing our trigonometry lesson. Right now we're in the section where we're discussing the graphs of all the trig functions. Now, for the previous two lessons, we have already described the graphs of sine and cosine and how they came about. So today we're going to go on to talk about other functions, the graphs of other functions which are related to sine and cosine. All the other graphs are related to sine and cosine because every other function is related to sine and cosine. For example, if we talk about sine and cosecant, cosecant is the reciprocal of sine. So we can get the graph, we can understand the graph of cosecant by understanding the reciprocal of sine. And secant is the reciprocal of cosine, and tangent is the ratio of sine and cosine, and cotangent is reciprocal of tangent. So every other graphs, the other four functions, their graphs we'll be looking at is going to be based on sine and cosine. Alright, so what we're going to do is let's go ahead and go back. There are several resources from the internet we can show you again. So this website will show us again is how does the graph of sine and cosine come from. You can pause and you can probably go to this website, analyzemath.com, and then take a look for yourself. You can look at sine and cosine. We can probably look at both. We did that last time, but I think let's just go ahead and look at sine again. So let's see how sine goes. Sine is again is the y over r, but when r is radius is 1, that y coordinate is that y segment value is the value of sine in a unit circle setting. And as your angle goes from 0 through pi over 2, pi through pi over 2, and back to 2 pi, this will be the first period. This will be the first period and of the sine graph. And so the period of the sine graph is going to be 2 pi because it takes 2 pi to completely for sine to completely go through all its unique values. And the amplitude is the we'll give you a more definite defined definition, but the amplitude is definitely 1. Is the unit is the magnitude in a sense of this wave, how high and how low it goes. It goes up to 1 unit above the average value, and then 1 unit below the average value, the midline. Okay, so that's why the amplitude is 1. All right, now let's take a look at sine. Let's take a look at cosine. So cosine value is the x value, which is the green segment represented by over here, and it started with 1. You go down to 0 at pi over 2, down to -1 at pi, and come back up to 1 at 0 and 3 pi over 2, and go back up to 1 at 2 pi. So its period is also 2 pi because so it has the same period with sine because it repeats itself. It completes the whole cycle, the first period in 2 pi. In the time of 2 pi, and the amplitude is also 1. Okay, the amplitude goes the maximum value is 1, the minimum value is -1, so it's 1 units away from the midline, from the average value here. So the amplitude is 1. Okay, now later on we'll be taking a look at tangent. There's another important resource we'll be able to take a look at is this website. It's called Function Libraries, and it gives us a very important function and relation library. This resource is very important. It gives us a lot of information on especially this chart here. So if we take a look at this chart, as you can see, this is a part of a unit circle. This is 1, okay, that's the radius. This is also 1, that's the radius. This is also 1, that's the radius. Now, from this unit circle, we can see that every function is a line segment. Okay, cosine is like this. This is the x coordinate of this point, as we have been before. This is the y coordinate of this point. Okay, so that segment is the y coordinate. This segment is the x coordinate. So this segment is cosine. This segment is sine. Now this is a tangent. Okay, so when we go ahead because that is the tangent, right? Remember, tangent defined in circle is that it's a line, it's a segment that intersects the circle at one point. So that's a tangent. So if you extend this radius out, and then you draw a line that intersects that extension of the radii of the radius, that segment is the tangent, and this whole thing from the center all the way to that intersection, that is your secant. That's the reciprocal. That reflects the secant. And if you keep drawing this, Okay, extend this the same radii, and then draw a tangent on this side. That would be the cotangent, and that thing would be the cosecant. Okay, so we can take a look at this a little bit later. But this website has a lot of information. It defines everything for you, and then it starts talking about the sine function. So it gives you the information on sine function, the basic graph of sine functions. Now notice the x-axis is the real number axis. It reflects the angle. Okay, it represents the angle or the arc length actually, because remember the arc length is equal to the angle. So if the angle is pi over 2, the arc length is also pi over 2 in a unit circle, because s equal to r theta. Alright, so sine theta goes like this, and it does keep going, so that's why it's a periodic function. Alright, so if sine function looks like this, what would the cosecant function look like? Well, because cosecant is the reciprocal sine. Okay, so we can look at certain key values to see what are the reciprocal values of sine. Alright, so let's take a look at that. Let's make a quick table here. Okay, we don't have to make too large a table. Let's just make some table values on key values. Let's start with sine. Let's start with 0. Okay, let's do cosecant, and then so this is 0 radian, and then pi over 6, pi over 4, pi over 3, pi over 2. Let's just do the first half. 2 pi over 3, 3 pi over 4, 5 pi over 6, and let's go to pi. Okay, and we can extend out the other values a little bit later. So sine of 0 is 0. Okay, cosine, and then it went up to 1/2, and square root 2 of 2, and then square root 3 over 2, and then 1, and then it comes back down, square root 0 over 2, square root 2 over 2, 1/2, and comes back down to 0. Then it keeps going. Okay, and then you have let's go and put 3 pi over 2 here, and then to go back to 2 pi. 3 pi over 2 is -1, and 2 pi it go back to 0. So because cosecant is the reciprocal of sine, so reciprocal basically we have to divide it, like kind of like flip it, but also just divide 1 over sine, right? So cosecant, let's go ahead and write this. Cosecant x is 1 over sine of x. 1 over sine of x. Okay, that's very important to remember their relationship, so that you don't need to memorize cosecant per se, but you just need to memorize the relationship between cosecant and sine. So if you know sine, you know cosecant. Okay, now, so what is 1 over 0? Well, that's a problem, right? Because 1 divided by 0, can we divide by 0? Not really. We can't really divide by 0 because it's undefined. There's no really answer. So there's something wrong here with the graph of cosecant. There's nothing at 0. When x equal to 0, cosecant is undefined, so there's not going to be anything. Alright, pi over 6, 1/2 is going to be 2. 2 over 1, so it's going to be 2 over square root 2. This is going to be 2 over square root 3, and this is going to be 1, because reciprocal of 1 is still 1. And here it's going to also be 2 over square root 3, 2 over square root 2, and it's going to be 2, and it's going to be undefined again. Alright, and then here it's going to be reciprocal. -1 is -1, but 2 pi is going to come back to undefined again. So we see there's several breaks. From 0 to pi, there's going to be a break, and those are going to be called our vertical asymptotes. When you divide by 0, this will be the vertical asymptote. Vertical asymptote. Alright, this is also going to be a vertical asymptote. Vertical asymptote. So in this function we have breaks. okay, in the function of cosecant, it's not going to be continuous. There's a break in the function. And but what happened between 0 and power of 6? It's very interesting. Like when you start from 0 going to 1/2, you're going to go through all the small numbers. So that means once you leave 0, once you sine goes to like 0.1, this value should be very large, because sine of 0.1, for example, let me give you an example. Sine of 0.1 it's a very small number. It's for example, sine of 0.1 is 0.0998. okay, 0.00998 is a very small number. So the reciprocal of that, so cosecant of 0.1 would be the reciprocal of this would be about 10. Okay, would be about 10.02, something like that, approximately. Okay, approximately. Alright, so that means it's actually start out with a very large number. So the closer you get to 0 in sine, the smaller you get. But that means the closer you get to 0 for cosecant, the larger number you will get. Okay, so let's go ahead and take a look at how this will actually work out. Now let's go ahead and use a graphing calculator to help us. Alright, so this graphing calculator, we have we're able to graph this sine. This is a regular sine graph. I can zoom out and you can see sine is continuous, right? You keep going, and then there's a periodic. It's periodic because it repeats itself and completes it goes through the same values over and over and over again. Okay, now as you notice, there's a little bit interesting thing here, because our grid in the x-axis is right now is in real numbers. There's no more real number. So as you can see, this point should be 3.14 pi 0, and this is approximately 6.282 pi. Okay, 0. But what we can do is we can change our axis. Okay, we can change to pi over 2 or something like that. So now we can see, oh, okay, we're graphing our x-axis in increments of pi. Okay, using increments of pi, and that will help us to understand this different quadrants and different sections of the graph more easily. You can see it's right here is pi over 2 is where you reach the maximum pi, and then go down to 3 pi over 2 and -1, and then come back to 2 pi is 0. So those are the major points that you need to know how to graph a sine function. We'll be talking about how to graph a sine function a little bit later. Alright, so let's go ahead and take a look at the cosecant function, and let's see what happens. So cosecant function definitely looks a lot different. Okay, let me turn off the sine for now. So this is what cosecant looks like. It definitely looks very different than the sine and cosine functions that we have seen before. And did you notice there's a break? There are breaks right here. There are vertical asymptotes at 0, at pi, and 2 pi. And why do we have vertical asymptotes at those places again? Because the sine function is at 0. Sine of 0 is 0, sine of pi is 0, sine of 2 pi is also 0. So therefore, cosecant functions have vertical asymptotes at those points. Okay. Alright, now let's take a look at sine functions again. So if we look at this together, now you can see actually it makes more sense. So as sine becomes not 0 anymore, it's a very small number, but its reciprocal is very large. That's why you can see the graph of sine cosecant is coming down. So as sine reaches 1 at pi over 2, cosecant also reaches 1 at pi over 2. Okay, because the reciprocal 1 is 1. And then as sine goes back to 0, the reciprocal increases up to infinity. So here it actually approaches infinity if you approach 0 from the left hand side, from the right hand side here. And if you approach pi here from the left hand side, cosecant, it also approaches infinity. So at pi there's nothing. But once sine goes from 0 go to negative, the first negative, then the cosecant reappears from negative infinity. So it goes from negative infinity up here and approach -1 as a maximum value, and then it goes down again to negative infinity as your sine value approaches 0 from the negative side. Okay, from the negative side it goes back to 0. So when it goes back to 0, cosecant again becomes undefined. Okay, so undefined, and then it goes from negative infinity, positive infinity, go down to 1, go back up to positive infinity, then another undefined, okay, and then comes from negative infinity up to 0, up to negative 1, then goes back down to negative infinity, and then undefined, and then it repeats itself. So again, this period for cosecant is also 2 pi. Alright, so alright, now let's go ahead and take a look at cosine. Okay, I'm just going to go on to let's take a look at cosine, right? Cosine start from 1, goes down to 0, goes down to negative 1 at pi, come back up to 0 at 3 pi over 2, and then goes to 2 pi at 1. So let's take a look at how does its reciprocal work, because cosine and sine, they're basically the same function, they just offset a little bit. So secant and cosecant, they should be the same, they should look the same, as you can see. Let's turn on the graph of secant. It does look the same, right? It also has vertical asymptotes at pi over 2, but it's a different place than secant. Because what happened at pi over 2? Well, at pi over 2, cosine equal to 0. Therefore, you have a vertical asymptote. At 3 pi over 2, cosine equal to 0, so you also again have a vertical asymptote. So secant is the reciprocal of cosine. Secant is reciprocal of cosine. Therefore, you follow the exact same opposite pattern of cosine. And as you can see, as cosine goes from 1, the secant also starts from 1. So cosine goes from 1 down to 0 because it's going towards 0. So here secant goes towards positive infinity. Then when cosine switch to negative, then secant starts from negative infinity and then increases its value towards negative 1. It will meet cosine at pi negative 1. Then as cosine increases up to 0 from the negative side, so it goes down to negative infinity. Then at 3 pi over 2, there's what do you call this? Asymptote, vertical asymptote. Yeah, vertical asymptote. And then as cosine value become positive and going back to 1, the secant goes from positive infinity down to 1 again. So that's what the secant graph is. And secant also has a period of 2 pi. It also has a period of 2 pi because it follows, right? You can see that it goes through it completely goes through all its unique values in 2 pi, from 0 to 2 pi, because cosine also has a period of 2 pi. Alright, let's go ahead and take a look at tangent. Tangent is very interesting because tangent is actually the ratio of sine and cosine. So if we take out tangent, take out sine and cosine, okay, sine is the red one, cosine is the green one. You divide them, as you can see, okay, starting from 0 divided by 1 is 0, right? And then pi over 4 is for sine, tangent of pi over 4, you will get 1. Now why is that? Because you can see sine and cosine, their pi over 4 value, they are the same. Okay, and tangent also has vertical asymptotes. Now the vertical asymptote is because tangent is sine divided by cosine. So whenever cosine is equal to 0, there's a vertical asymptote. So there are vertical asymptote at pi over 2, and there are vertical asymptotes at 3 pi over 2. So tangent is very interesting because it goes from 0, it increases up to infinity towards pi over 2. Then after pi over 2, it comes back from negative infinity, increases to pi at 0, and then it will increase up to positive infinity towards 3 pi over 2. Then after you pass 3 pi over 2, tangent comes back from negative infinity and then does the same thing. So it does. Do you see that it repeats itself? It repeats itself now, not every 2 pi. Yes, every 2 pi it will repeat itself, but it actually repeats at a faster period. It actually repeats itself every pi. Okay, so you can see from 0 to pi, okay, it goes through all the infinite, all the unique values of this function. So it just keep going like this. Okay, and cotangent will be the reciprocal of this. So if this reciprocal of this is actually cosine divided by sine, so it actually does looks like just like tangent, but it goes from a negative direction. Okay, it goes the opposite direction of tangent. It goes from 0. The asymptotes will be at 0 and pi, because sine is equal to 0 and pi at that time. And so it will go from positive infinity, and then let's just go through pi over 2 and all the way down to negative infinity. Okay, so cotangent also says period of pi. Alright, and we will be talking about this So if you look at compare tangent and cotangent, okay, you look at a little bit different. So we will be able to talk about their properties a little bit more in detail next time, but this time I would just like to show you how does the graph look. And this website is a very interesting website. It's called Desmos, DESMOS.com, and you can go ahead and use this website to graph something and then explore. You can explore there are different ways. You can put in different functions, turn them on, turn them off, and you can use them to play around and then zoom in, zoom out, and see how the graph looks like. And it can show you important features of the graph. So, all right, so let's go ahead and come back to this this page. Okay, this is the function and relation library. So here, if you look at the sine function, it gives you a lot of the information we already talked about. This is y is equal to sine x. That's the function we're graphing. The opposite function is negative sine x. Okay, its reciprocal function is cosecant x. Okay, the cosecant, and the inverse function is arc sine. Now we haven't talked about inverse function yet. We'll get to that in a few lessons down the road. Then the slope function, that's also y equal to cosine x. That's has to do with this slope, which is the derivative, or basically when we deal with calculus, that's a very important fact that you need to know. And the period here is 2 pi or 360 degrees. What it means is that it completes all its unique value. It goes through the unique value. It goes through cycle in 2 pi in the time. Now the x-axis can be considered to be a time. Okay, that's why we call period. Period is how long it takes for the function to complete its cycle. So one cycle is 2 pi. It takes about 6.28. Well, you want to call seconds or minutes, doesn't matter. But that's unit of time here. Is how long it takes to complete its cycle. The range is the maximum value and the minimum value of a natural sine function. So it's from the maximum value is positive 1, the minimum value is -1, and the amplitude is 1. Okay. Now sine function is also very useful. In sine and cosine, they're so very useful. They're fundamentals. They're very fundamental to a lot of higher order mathematics and more advanced mathematics and science, and especially in physics as well. So this is a little glimpse, a little preview of what you would have to deal with later on in calculus if you keep going to calculus. Now let's look at cosine. So again, cosine we have already discussed. It goes basically in this, it's the same shape of sine, but there's an offset, there's a phase shift of 90 degrees, or pi over 2. So you start out a little bit early. Now, so its opposite function is negative cosine, its reciprocal function is secant, okay, secant, and then its inverse is arc cosine. Okay, we haven't talked about that, we'll deal with that later. Its slope function, now pay attention, it's very interesting, it's sine, but it's negative sine. So sine and cosine, they're each other's slope functions, basically. Its period is also 2 pi, okay, and the range is the same from -1 to 1, and its amplitude is also 1. All right, okay, and so as you can read the description a little bit later. Alright, so as you can see, we have some more description of cosine functions here. X over r is the ratio we have talked about, and again it gives us a little bit of preview of what you will be seeing is as a sequence expression of cosine, and this is very important as we go to calculus. Alright, cosecant. Okay, cosecant is the reciprocal of sine, and as you can see, we already talked about that. Now, a little bit detail is cosecant here. It is infinite or undefined, actually undefined, because we divide by 0 when at this point when it is 0 plus k pi over 2. So every time you have multiples of, well, actually, I'm not sure if that's accurate, but we'll, yeah, it starts with 0, okay, and so every pi, starting from 0, every multiples of pi, you will have a asymptote, vertical asymptote. It will be undefined. Its opposite function is the negative cosecant x. Its reciprocal function is sine x. Inverse is arc cosecant. Okay, the arc cosecant is less useful, but we're not going to use that too much. But anyway, its slope function is negative cosecant times cotangent, and its period is 2 pi because it follows sine. And the range, let's pay attention to the range. It goes from negative infinity all the way to negative 1, and then it'll go from positive infinity, it goes from 1 all the way to positive infinity, but there's nothing in between 1 and negative 1 because it's reciprocal of sine, so it has nothing, no value between negative 1 and 1. Okay, that's a key. So the most important thing is you have to understand this range, this period, and this where the asymptotes are, where the vertical asymptotes are, is where it is undefined. All right. So where it is undefined is when sine is equal to 0. Now secant is the reciprocal of cosine. So secant its opposite is negative secant. Its reciprocal function is cosine. We have arcsecant function as well. Its slope function is secant times tangent. And the period is 2 pi because it does follow the period of cosine. So from 0 to 2 pi, it will complete its first cycle. It will go through all the unique values of the function. It go through everything once, at least once, and then it follow the pattern. Now the range is the same. The range is basically is going from negative infinity to negative 1 and from 1 to negative infinity. So again, secant has nothing between negative 1 and 1. Negative 1 and 1. There's nothing in between those two values. Now, where is asymptote? Well, you start from pi over 2. So every time you have a pi over 2, you plus minus m pi. Okay. So starting from pi over 2, you plus 1 pi, 2 pi, 3 pi, and so on and so forth. Then you will, or you subtract 1 pi from pi over 2, then you will have an asymptote, because that's when cosine is equal to 0. Now tangent is a little bit different because tangent is the ratio of sine and cosine. It is sine divided by cosine. So this period is pi, or from 0, and then its range is from negative infinity. It covers everything, negative infinity all the way to positive infinity. Okay. And where its asymptotes are is, again, is the position where cosine is equal to 0. So at pi over 2 and plus minus m pi, because every time you go from pi over 2, you plus 1 pi, plus 2 pi. From pi over 2, you will reach asymptote here at tangent. Cotangent follows the asymptote position follows sine. Whenever sine equal to 0, cotangent will have asymptote, vertical asymptote. And this range is also negative infinity to positive infinity, and its period is pi. Okay, so here you should be able to go ahead and then use you can refer to this website. Okay, you can refer to this website and come back to use this as a very good reference, and we will be talking about this information in the later video and try to tabulate everything and to make it more organized. Alright, so if you have any questions, any comments, please leave it in the question and comment section, and then hopefully we'll see you in our next lesson.